Okay, so this is module 10 review with random samples and populations, not populations, sorry. Populations. So the first one is going back on population and samples. Remember, population is the whole group. Sample is a small group that you graph randomly from that big group. But you have to be careful with bias in the questions or groups. So like for instance, if I want to see if the city wants a new park with the basketball court, and if I go as basketball players, then of course it's gonna be a bias sample. But if randomly pick people coming up from a store, then that will be a good random sample to pick. Also, the question that I ask is gonna kind of affect the way people answer. So like if say, what do you think about utilizing our tax money for something good and healthy to promote wellness and create a new or build a new park with the basketball court? So people are gonna be inclined to say yes. But if you say, what do you think about wasting our money, and opening a park where people are gonna go and they're gonna be safe and children are gonna be with adults playing basketball, whatever the case may be, that's not gonna be a good question. Okay, so just be careful with that. And then for making inferences, so this one is a little more mathematical because we do have to use proportions, which I like. So in this one, we're gonna make an inference given the information. So we have 250 students in the school, and then we get a sample of 50 kids, and then 7 of those 50 are the only child, so they don't have any siblings. So we want to predict the number of students that are the only child in the whole school. So then what we want to do always is the event, which is being only child, over the total, right? So I have the sample, so I have 7 kids out of 50 are the only child, but then the actual population, so this is my samples, my population is 250 students. So an easy way to go on this one is, what did I do to 50 to make it 250 multiplied by 5? So I multiply by 5 here, so I get 35. So the prediction is that about 35 students are gonna be the only child. So that other way you can do is the butterfly way that I show you. So that you do 250 times 7, and then you divide that by the only one by 50, and you end up with the same answer. So about 35 kids are the only child in the population of 250 students. Okay, last one, generating random samples. Remember, we did it with the dice in class, we did it with the little strips of paper in the video. So different ways to do it. You can do it with the website that I show you, or you can even do it with calculators if you have a scientific or graphing calculator. So in this case, we have 10,000 phones, and 600 of them are broken or defective. And so imagine that you are in charge of, to see how many are broken in the batch that you get. And so for you to do that, you're gonna choose numbers 1 to 600 to represent the broken ones, because that's how many are broken in a batch of 10,000 phones. And so then you get a sample of only 5 numbers, and then you have this ones right here. So in this case, remember 1 through 600 are broken. So that means that this is gonna be broken, this one's gonna be broken, and that's it. Okay, so in this case, 2 out of 5 are broken. Let's see if that's a good sample that you chose, and then if not, why. Okay, so based on this sample with only 5, you figure out that basically 40%, because divided by 5 times 100, that's 40% of the phones are broken. And let's just do proportions and see if that equals. Okay, this one's right here, they say 600 over 1,000. Remember, 10,000. Remember, you can do this. So in this case, you have 6 over 100. If I simplify by 2, I get 3 over 50. Okay, so 2 and 5. Again, this is 40%, and this is, if I want to, it's scary, but it's easier this way. This is actually 6%. This and this is very different. Okay, the other way that you can do it too, but it's not gonna be as effective, as if you go 2 over 5 and then multiply this 2, that's 200, and this is 30. They're not equal, so right away you know there's a big difference. Because when they're the same, then that means that the two fractions are the same. So this is a bad sample because it's very few. You only pick 5 to represent those 600 broken phones. So this is not a good sample because it's too little compared to the big batch of phones. Okay. Now if you were to pick like, I don't know, 100 numbers or something like that, then it will be a little more precise and more in comparison to the actual reality of 600 broken phones in a batch of 10,000 phones. Okay. Alright, remember a sample needs to be a good size, randomly picked, and when you're asking questions, they have to be good questions and no biased questions. And then again, you can use whatever you have from the sample to make your inferences and predict some outcomes. Alrighty, God bless you. Bye.